Hi, Washington Liberty Chemistry students. This is the third part of your lesson on elements, compounds, and mixtures. And we're going to talk a little bit about separating mixtures. In the last two videos, we talked about the difference between a pure substance and a mixture, and the fact that elements cannot be broken down into simpler substances. Compounds can only be broken down into their elemental parts by a chemical change. But mixtures can be separated somewhat more easily by exploiting physical changes and physical properties. And we're going to talk about three ways to separate mixtures here. So, mixtures can be separated based on the physical properties of its components. Three common methods of separation are distillation, filtration, and chromatography. Now, the physical properties that we use to separate mixtures using these techniques are listed below. Distillation separates mixtures by differences in boiling point. The mixture, the components, boil off at a different time and a different temperature. Filtration separates mixtures of undissolved solids from liquids by particle size. So in other words, if you have a heterogeneous mixture like sand and water, you can likely catch the sand or most of the sand in filter paper. Now, when particles are really small, like dissolved particles, they don't catch. But if they're large enough, they will catch in filter paper. Chromatography is a technique you may or may not know about, and we're actually going to do a lab on this. Chromatography separates mixtures based on attractive forces between particles in solutions, and we'll talk about that. Let's just look at a picture of a distillation apparatus. Distillation is the process of separating components of a mixture based on different boiling points. And you're probably familiar with evaporating water off of salt water and leaving the salt behind. And the only difference with distillation is that we want to recapture that water. You may have even done solar stills, or that might be a good science project in which you recapture the water. This is a very fancy distillation setup that you can use to capture both the salt and water in a mixture. So what you do is if you have a homogeneous mixture of salt water and you're like, I want the salt back, or I want to get the salt out so I can drink the water, essentially what you do is you heat, and you know that sodium chloride boils, even melts, at a much, much, much higher temperature than water. So by boiling off the water, you can leave the salt behind and separate out the two components of that homogeneous mixture or solution. Now, how do we catch the water? Well, as the steam goes up, rather than let it just escape into the air, we catch it in this tube apparatus. And this tube apparatus has water on the outside that is cold. And so as you know, when steam hits something cold, it recondenses, and then we can separate out the distilled water. Now, there are more complicated distillation apparatus where you can actually separate components that are liquids dissolved in liquids, like alcohol dissolved in water. And you do that because alcohol does boil at a lower boiling point than water does. And so you can literally do something called fractional distillation, just continue to boil and separate, and get purer and purer amounts of alcohol, because the alcohol will boil off before the water that's left behind. So examples of uses of distillation include the purification of alcohol, of taking salt out of water, of crude oil refining, because the parts of the oil that we use boil at different points, and even doing things, there are gas distillations where you can liquefy gases from the air. But just to go back, it's based on differences in boiling point, which, as we know, is a physical property. Now, filtration is really better for heterogeneous mixtures. And filtration is a process by which impurities or particles are removed from a fluid, usually a liquid, sometimes a gas. The liquid is poured over a filter, and the filter is not so porous that it will allow particles of a certain size to pass through. So dissolved particles will pass through a piece of filter paper, but ones that are not dissolved will be caught by the filter paper, and the liquid will be able to go through. And so this residue is the particles, like within sandy water, that can't make it through the filter paper pores, and the water can, and so we are left with what's called the filtrate, which is the water that's able to move through it. So this is good for mostly heterogeneous mixtures. Salt water it won't work on because salt water is so well dissolved in water that it just passes through the pores of the filter paper. And then finally, let's talk a little bit about chromatography. It's the separation of a mixture by passing it in a solution or suspension or as a vapor, there are a lot of different kinds, through a medium in which the components move at different rates. Now, the kind that we're going to look at, and the simplest one to understand, is the components of ink. Ink is a mixture of different colored pigments that are dissolved in a medium, sometimes in water-based ink. And you might have blank ink, but it is actually a mixture of a bunch of different components. Now, if you spot it, put a sample of it on a piece of filter paper. You may know that if you put the end of the filter paper in water, the water will slowly move through the filter paper. It'll be absorbed up the filter paper. And as it goes, some of the colors, some of the parts of this ink mixture are really attracted to the water and tries to move along with the water. And some are not. Some are more attracted to the paper. And so because of the differences in the rate at which they move over the paper, the different components of this black ink reveal themselves. In this black ink, we have both purple and red and yellow and blue, the blue being more attracted to the water and the purple being a little slower and staying on the paper longer. So it's a way of identifying inks. Inks actually have kind of fingerprints, formulations that they can be used for identification. So here's an analogy. If you think of the black ink as being a mixture, and it might be a little hard to see here, but a mixture of wasps and bumblebees. You put it on the beginning of the paper, you spot it on the paper, and you have them going over flowers. Well, the bees are attracted to the flowers, but the wasps are not. So as you have them move across, like the paper as the flowers, the wasps get ahead because they're not interested in the flowers, whereas the honeybees slow down. And therefore, after a certain length of time, you have two distinct groups, the wasps and the honeybees. And that's what's essentially happening with the inks. Now, this is very characteristic how fast they move up. And it can be used in all sorts of identification. So, for example, it's often used in forensics. So this is a chromatography, a developed chromatography paper from a separation of a white powder that was found at a crime scene. And the detectives at a crime scene suspected that the white powder they found was an illegal drug. And so they took it back to the lab and they spotted it against known drugs. And each one of these drugs are pure substances, so they only have one. They're compounds, they only have one spot, but they characteristically are attracted to this paper. So the cocaine here was very attracted to the solvent, less attracted to the paper, traveled a lot. Heroin, which is a compound, so only one spot, was a little bit attracted to the paper and moved slower. And the methamphetamine moved the slowest. Now, when you develop against the unknown, you can see the unknown white powder was actually a mixture. It was a mixture of all three of these illegal drugs. So just to summarize our three lessons, we have now categorized matter into pure substances and mixtures. And pure substances are elements, which consist of only one type of atom, and compounds, which consist of more than one type of atom, but they are chemically bonded together in molecules. Mixtures, on the other hand, are not pure substances. Now, a homogeneous mixture is very well mixed. The composition, the top and the bottom is the same, but they consist of different kinds of pure substances mixed together very well. They're sometimes known as solutions. Heterogeneous mixtures, on the other hand, are mixtures that have variable compositions, but again consist of different types of particles. And homogeneous and heterogeneous mixtures can be separated based on their physical properties. Compounds can only be broken down into elements by chemical reactions, and elements cannot be broken down at all. So that is your lesson on classifying matter.